Hi students, today's topic is refraction through a prism. So in this case we are going to derive an expression for angle of deviation and also refractive index of the prism. So let us consider first a prism ABC. So at least it must be isosceles if not equilateral. I mean all the three angles 60 if it is equilateral prism. Otherwise if it is isosceles prism, then B and C will be equal to each other, whereas A can be any other angle. So now let us consider a ray incident on the prism. Of course, let me just mention here, AB is one refracting phase, AC is the second refracting phase, whereas BC is the base of the prism, which is non-refracting. So now let us consider a ray of light incident on the face AB. Say PQ is the ray. Instead of going straight along this dotted line here, dotted path, so it will undergo refraction at Q. So to understand the refraction, let us draw a normal here. So to this normal, it makes an angle I as the angle of incidence. Angle of incidence is I here. This is the normal. And the ray here bends towards or away from the normal. It should bend towards the normal, assuming that the prism is made of some denser medium compared to the surrounding. Like for example, prism is made of glass and surrounding medium is air. So the ray is bent towards the normal. This is the normal here. The ray, instead of going straight, it is bent. The angle between the normal and the refracted ray is R1, where QR is the refracted ray and R1 is the angle of refraction. So incident ray is PQ, QR is the refracted ray. So now at point R, the ray QR, instead of going straight, it will undergo once again refraction. So to understand that, let us draw a normal first. So what is the angle of incidence here? R2. R2 is the angle of incidence at the second phase. So now the ray, instead of going straight, it will bend. So it will appear to come from somewhere back here. So at R, the ray is bent now along RS. So RS is the emergent ray. So PQ is the incident ray, QR is the refracted ray, RS is the emergent ray, the ray which is emerging out of the prism. Now you can see here that the two normals which we have drawn to the two faces, they are crossing at point N. So now angle of emergence can be measured as angle between normal to the emergent ray. So of course for the first phase, I is the angle of incidence, R1 is the angle of refraction. For the second phase, R2 is the angle of incidence, E is the angle of emergence. That is angle of refraction actually. Whereas see, as a basic principle of light, any ray of light can retrace its path back. If SR becomes the incident ray, then RQ will be the refracted ray and QP will be the emergent ray. In that case, E becomes I becomes E. So in that case, R2 becomes R1 and R1 becomes R2. So in this way, we can just remember here that R1 and R2 are the angles of refraction when either E is the angle of incidence or I is the angle of incidence, like that. So generally we are taking I is the angle of incidence, R1, R2 angles of refraction inside the prism, and E is the angle of emergence. So then M is the point where the incident ray and the emerging ray appear to be intersecting. So this is the basic ray diagram for refraction through a prism. And you can see here the angle delta I have shown. This is the angle between this incident direction PQM. So this incident direction and the emergent direction MRS. So RS and PQ, the two rays, the incident ray and the emergent ray, the total amount of bending, the emergent ray to incident angle, that angle is called as angle of deviation. The total angle by which the incident ray is deviated towards the emerging direction. So that is angle of deviation we call. So we are going to derive an expression for this angle of deviation and also the refractive index of this prism with respect to the surrounding medium. In the quadrilateral AQNR, R and Q are right angles. AQNR, that is this quadrilateral, the shaded area you can see here, gray area. So AQNR, this is the quadrilateral. In this, angle Q is right angle 90 degrees, angle R also 90 degrees, you know that, because these are the angles made by the normals actually. Now what about angle A and N? We don't know. So angle A is angle of the prism, that's the standard value, and N we don't know. So now inside a quadrilateral, the sum of the four angles must be 360. In that 360, 90 and 90, this is 180 over. Now remaining 180 is shared by A and N. Therefore, angle A plus angle N should be 180. So QNR is one angle, A is another angle. So that sum must be equal to 180. This is for the quadrilateral AQNR. Now similarly, let us take the triangle QNR. This QNR, you can see the shaded area here. R1 and R2 are the angles of refraction. QNR is the third angle. So inside the triangle, the sum of the three angles must be equal to 180, you know that. So R1 plus R2 plus QNR, this angle must be totally, they must sum to 180 degrees. So R1 plus R2 plus QNR must be equal to 180. Now look at these two equations here. QNR, 180, 180. So comparing the two equations, we get angle A equal to R1 plus R2, that is equation 1. Then the deviations. Now, how much is the deviation of the incident ray here? Earlier I was telling you, the incident ray and the refracted ray, emergent ray, the total angle is deviation delta I said. But let us check step by step. The ray, incident ray goes like this, PQ, and instead of going straight, it is bent towards QR. How much it is bent? This is called deviation at the first phase. So this is delta 1. So delta 1 is equal to I minus R1, because delta 1 plus R1 must be equal to I, you know that. So therefore I minus R1 is equal to delta 1. So that is delta 1 is equal to I minus R1. Let me take. Similarly, at surface AC, the ray here, say QR is the incident ray now, RS is the refracted ray. So this refracted ray to emergent ray, how much is the bending? So instead of going straight like this, it is getting bent. That I will show as the angle here, the shaded red colored area, delta 2. See, instead of going straight, it got bent here by an angle delta 2. So how much is this angle? Of course, you can understand that this is R2. So means this is R2 here opposite. And this total is E, you know, the angle of emergence. So E minus R2 is delta. That is what I have taken here. Delta 2 is equal to E minus R2. So what is the total deviation then? Delta 1 plus delta 2 is equal to delta, the amount of bending from incident to emerging ray. So in two steps the deviation happens. The total deviation is delta 1 plus delta 2. So therefore the total deviation is given by delta 1 is I minus R1, delta 2 is E minus R2. If I substitute, delta is equal to so much you get. Now what is this R1 plus R2 is A. See this minus R1 plus R2, I will put it as A here. I plus E minus R1 plus R2, that is A here. So I plus E minus A. This is equation 2. So remember equation 1 and 2. Angle A is R1 plus R2. Angle delta deviation angle is I plus E minus A. So we derived an expression for angle of deviation actually. So one step is over. Angle of deviation we derived. Now let us check how to derive the refractive index. How to get the refractive index also. So then let me just take now again some small setup here. Say this, look at this diagram. Say in this, as I go on increasing the angle of incidence, decreasing the angle of incidence. So first, what is angle of incidence here? So when I keep it here, the angle of incidence is 0. So now when I just do like this, angle of incidence I is increasing. Okay. So now I becomes maximum here, 90 degrees, like that. Now as I change the angle of incidence, you just keep looking at this D here, angle of deviation. So look at the value of angle of deviation. Now when the angle of incidence is maximum, D is maximum. As I decreases, D also decreases. Then it reaches some minimum value, then again it increases. See, D is increasing now, though I is decreasing. See, D is more here. Okay, deviation is more when for the smaller angles of I. As I increases, D decreases to minimum somewhere here, and then again increases to maximum. So you can even look at the values here. Now I will just see where this D becomes minimum, the angle of deviation becomes minimum. Say somewhere here, when this refracted ray is exactly parallel to the base of the prism BC, you will find that this D is minimum value. So D is minimum here. You can say D is equal to I plus E minus A, which is 37.2 it is found. Now if I increase I or decrease I, if I increase or decrease I, this angle of deviation is going to be more. You can see that. See, it is increasing there. This side also it is increasing. This side and this side both angle of deviation is more. You can look at this value. Whereas at some point here in between, so you will find the angle of deviation is minimum that is when a refracted ray is exactly parallel to the base of the prism. In this case, you will find that when the refracted ray is parallel to the base of the prism, according to the basic principles, of course, because the refractive index of this glass is same when you are talking about second surface or first surface. Therefore, if this ray, refracted ray, is parallel to the base of the prism, then R1 must be equal to R2. These two are parallel, so R1 must be equal to R2. Then that implies I must be equal to E. So when the deviation is minimum, I is equal to E, and also R1 is equal to R2. So a graph of delta, if I plot this delta value, actually in the video here I have taken D. Actually you can even take it as delta or D is fine, no problem. So this value of delta or D is plotted against I, angle of incidence. So what did you understand? Angle of incidence is increased, deviation first decreases, then becomes minimum, then again increases. So at this point where R1 is equal to R2, there I is also equal to E, I said. So I is equal to E in this case. So when delta is plotted versus I, the graph found is as shown, and in this we can say when the deviation becomes minimum, that is delta is equal to D minimum, deviation minimum. So we find I is equal to E and R1 is equal to R2. So at this point, now if I take that equation 1, so if you look recall the equation 1, A is equal to R1 plus R2, that was equation 1. So A is equal to R1 plus R2 gives you R1 and R2 are same, therefore R plus R is equal to 2R, we can say. So A is equal to 2R, otherwise R is equal to A divided by 2. So we got angle of refraction here. So then similarly, there is one more equation we got. So D is equal to I plus E minus A, delta is equal to I plus E minus A. This is equation 2 we derived. So in that equation, I will substitute I is equal to E and R1 is equal to R2 is equal to R, like that. So I is equal to E if I substitute here, so 2I. So D is equal to 2I minus A, we can say. So I plus I minus A, that is 2I minus A. So if I rearrange this, D minus A becomes plus A this side, so D plus A is equal to 2I. So therefore I is equal to D plus A by 2, that is A plus dm by 2. This is equation 4. So I got an expression for R, I got an expression for I. So I and R, if you know this, I and R if you know, then you can apply Snell's law to get the refractive index. That's simple. What is Snell's law? Snell's law says sine of the angle of incidence by sine of the angle of refraction is equal to relative refractive index of the medium. So applying Snell's law, we get N21 is equal to sine I by sine R, that is sine of I is here A plus dm by 2. What about R? A by 2. So therefore you will find sine of A plus dm by 2 divided by sine A by 2 as the angle of refractive index. So this is the expression for refractive index. Now in case if this prism is very thin, for a thin prism, dm is also very small, this deviation angle will also be very small. The angle of prism, if it is less like 10 degrees or so, if it is very small, then you will find deviation is also very small. So thereby sine of angle of theta is equal to sine theta, sine of A plus d by 2 is equal to A plus d by 2, sine of A by 2 is equal to A by 2. So I can just divide 2 and 2 gets cancelled. So thereby N21 is equal to A plus d by 2 divided by A by 2 comes. So 2 cancels, A plus d by A comes. So now if I divide further or cross multiply, N21 into A is equal to A plus dm. Now this A I will take to the other side. So D is equal to N21A minus A. N21 minus 1 into A you get. So this is the deviation in the case of a thin prism, and this is very very small because refractive index itself is very small. N21 is what? If it is glass and air surrounded by, so then N21 is 1.5. So minus 1, 1.5 minus 1 is 0.5. 0.5 into A. A is what? A is angle of the prism, which is very small, we have taken already for a thin prism. So if A is 10, then 0.5 into 10 is just 5 degrees. So this is showing you that thin prisms do not deviate light much. So this is about refraction through a prism. So we arrived at expressions for first we showed here deviation for thin prism, actually deviation by a thin prism, and also we derived expression for refractive index here, right, and also an expression for generally deviation, that is here equation 2. Thank you all very much.